Yeah, just started right now.
Okay.
Thank you.
Okay, so I will quickly go through some slides that I already have, so that we're on the same page about the PLE. So, okay, so the PLE is applicable when you have a bunch of a set of closely related products, which are, so to speak, all of them are very similar but different in some details in there. And you want to develop a set of artifacts for that set of products. So requirements, models, simulations, documentation, whatever in there. So the question is, how do you organize that work? So of course, nowadays nobody works with the clone and own approach, where you let's say create an entire thing for one product and then copy it and modify for other things, so that way comes to stop very quickly when you have to make a modification across all the things, and you cannot do that. So that's why the more comprehensive solution is necessary, and that's why PLE. So in layman's terms, if you have one product and let's say it's cost you X amount of effort to develop that, so if you have a 10 unrelated, so now if you have instead of one product 10 products, and if they are unrelated, the cost of development that would be 10x. But if they are related, and especially if there is a lot of commonality between them, the cost should be much smaller. So let's say twice as much as just developing a single product. So okay, so this is what I have in mind. So how to capture that? So basically, what we need to do is to develop a single model which captures all the variability inside or reflects all the variability inside that system model, and then annotate that with some data which tells which parts of a model changed somehow in one variant or another. So basically, yeah, we have a system model covering all variability, and since this is a bigger than quote-unquote real-life model, so it's often called 150% system model. So we have that, then we annotate it, and the annotations or the places where this model changes, they're called variation points. So basically, we demarcate the system model, each variation point, how this place in the model needs to change depending on some circumstances. And now how to capture those circumstances, or what's called configurations or feature models inside. So basically we need to have a so-called feature model, which is basically a description of what can possibly change. And this description is a very shorthand description, so to speak. It needs to be, so if let's say there is some option to have something or not, let's say car may have a sunroof or not, we want in our feature model description for this to be laconic. It's just like a single switch in there. So switch for sunroof, yes or no. And of course, so the entire feature model would be a bunch of these options, so to speak, grouped into one feature model. And then what we define is we define the configurations, which is a sets of values of those choices made, so to speak. Let's say we have a luxury configuration of a car which has a sunroof and all the bells and whistles switched on, whatever. In the feature model, maybe we have a budget configuration which has most of the things switched off, and so on and so on. So for each of these configurations may describe a different set of choices made. And once we have these three things, so the system model with the variation points and feature model and configurations, we can ask then the tool to realize a particular variant, or to say, I want a system model for this configuration, for let's say I want a system model for luxury configuration. And the tool must take this 150% system model, take the configuration, and build you a system model for a particular variant. Maybe removing some stuff, maybe changing some other stuff in there. Okay, so about these variation points, there are basically two kinds of them. So one is what we call existence variation point, meaning that some things exist and sometimes exist or not, depending on the configurations, as this my sunroof example was previously was. So sunroof exists in some configurations of a car and does not exist in other configurations of a car. So that would be an existence variation point, and the tool would go into your model and retain or delete the sunroof depending on your configuration in there. Another kind of variation point is update variation point. So where we don't want to remove some stuff in particular configurations, but maybe we want to change some stuff. So let's say we have some component mass, like a mass of a car, and we want to say, okay, the mass of the car is such and such in this configuration and a different number in another configuration. So we are not adding or deleting stuff here, so it's not an existence variation point, it's a modification variation point. So that would be another flavor of these variation points. Okay, so we just talked about this. So system model is separate. Okay, so the important thing to remember is that feature model, as I talked about, and the system model are separate. So the feature model does not have any quote-unquote real-world information, meaning if we have a feature, an item for a sunroof in our feature model, that's just one item. It's not a block. It doesn't have parts. There are no wires. There is no electricity in there. There is no mechanics. There is no mass in this. It's just a boolean, a toggle, a switch in the feature model, and that feature model is separate from a system model where you do have real realization of a system with all the real life parameters, like again, like masses, electricities, blocks, connectivities between the things, the push button on the core panel, some wires going to the sunroof itself, and so on and so on. Okay, so now about the Magic Draw PLE solution in general, and we'll jump into the model-based PLE in shortly. So basically, PLE in Magic Draw comes in two parts. Basically, we have PLE core, which implements the core PLE feature, this variant realization feature, which allows you to take the model and cut and rearrange it depending on particular conditions. But this PLE core must have, in addition, a sub-plugin for a particular methodology. Of those methodologies, we recently had only two, so the integration with Big-Lever-Gersten Pure Systems Pure Variants. So if we talk about those, so those are PLE tools, and to do PLE, you would have let's say PLE core plus Pure Variants integration sub-plugin, and then you would do your feature model and configurations in the Pure Variants tool, and your system model inside Magic Draw, and there was an integration, and it allowed to cut and rearrange Magic Draw models depending on the choices that you made inside this Pure Variants tool. But now with the 19.0 SP3, we are releasing our own implementation of PLE, which we called model-based PLE or MBPLE, which allows us to do the entire thing, meaning the feature model and configurations inside the Magic Draw, and then cut and rearrange Magic Draw models without a need of any third-party tool. Okay, so okay, we'll talk about these items in there. Okay, so let's repeat. For PLE, we need to have four things. So the multivariant system model, annotated with variation points, a feature model which describes in a succinct way possible options or possible choices or possible features. It's different terminology sometimes used, and then we need to have a recorded configurations, sets of choices made, And once we have these three things, we must have a procedure to build a variant system model or a 100% system model out of the multivariant system model and the particular configuration. So if we look how it's done in Magic Draw, the feature model. So abstractly speaking, as I said, the feature model is if we want to look into to have a metaphor, it's like a panel of switches. So it's a description of what options are there. So it's a set of choices, each describing a set of possibilities. And in our case, so in MBPLE case, it is realized as a class or / block model in there. So if we look into, this is a screenshot in there. So each of the properties in this class diagram in here, you see a little F letter near each of them. So it's each of these properties, we call them features in here. So yeah, this is a just lightly stereotyped class model, basically. So each of the properties are stereotyped with the feature stereotype, and the classes in there are stereotyped with the feature group stereotypes. So FG, you see the demarcations FG on the boxes in there. So basically, the classes are feature groups and the properties are features inside. And one of the feature group is demarcated as a root feature group. So you see the feature model class in here. It's demarcated with RFG, so that's root feature group. So which describes the root of our feature tree. So if we look now into this feature example of a feature model, so this is a feature model, let's say for some hypothetical car, and for each of the option that our car line has, we have some property in there. So if you see in the middle of the feature model, I have an option for a sunroof, and you see it has a type Boolean. So this means that the sunroof option is only a choice of yes and no. So that's how we describe that there can be a sunroof in our cars, and it's optional. Now for some other features like an engine, let's say we have 4 choices of engines in there. So we place a property, a feature inside our feature model, and we set its type to this enumerated type for engine. So, and we list all enumerated possible choices in there. So for, let's say we have an engine for 1.8 liter, 2.2 liter gasoline engine, some diesel, and some hybrid engine maybe. So, okay, so the list of features would be, so the features would, abstractly speaking, it's just a list of the features or a bag of features. But since this bag of the features can be quite large, so in real life car models, there can be hundreds of these features. And even thousands and even more of them. So nobody wants to place all the features inside just one big box with 1,000, let's say one class with 1,000 of items inside. So you do one subgrouping, and this feature groups is a way to subgroup these features. So let's say we have a subgroup for interior features in there, and we attach that to our main feature model with composition association, and we place our interior related features inside that subgroup in there. And this correspondingly here, I have some features for exterior and some features for safety and so on. And these feature groups in turn can have an additional subgrouping. Therefore, the feature model, the large feature models are usually trees of the features. So it's not just a single level, not even 2 levels, but there may be 3 or more of these levels of the features inside our feature tree. Okay, so now if the feature model is a class model, or BD, you can also use BDD for that. The configurations or the choices made are then maps very well to the instance model. Okay, so I skipped one slide in there. So you can look into this feature model in the diagrammatic format as they have in here, or you can look into the containment tree or a structure tree. So you can use any Magic Draw's visualization means to look into this feature model. So it's just a class model with light stereotyping in there. Also, what's important is that you can use Magic Draw's modularity or modularization features, meaning that you can, let's say, place your feature model inside the Magic Draw module or a used project, so to speak, and use the same feature model for multiple projects. So maybe the same feature model is controlling both your engine project and transmission project and main car project and whatnot. So you can use Magic Draw facilities to manage this feature model. Okay, so once you have a feature model, you may want to define configurations. And as I said, configurations are implemented in this MBPLE approach as an instance model. So the feature model is a class model, configurations are an instance model. And basically, so you take your root feature group class and make an instance for that, and that would be your configuration. So now, so here you see the instance model for my feature model before. So I'm making a fancy configuration of my car, which does have like all the bells of this and whistles switched on and so on. Now, how to create these instance models? Of course, you could use Magic Draw like diagramming tools and create an instance and fill the slots and whatnot in there. But that's how to say, that's a mouthful or it's a lot of tedious things to do. You can use other Magic Draw capabilities for creating instances. For example, we do have a wizard for creating instances for these deeply nested class models. And go to tools and create instance. And there is a special wizard for instantiation. So it opens you this your class model, which is in this case our feature model, and you can enter values for each of the properties described in that class model. So you could pick a value for an engine, pick values for exterior properties and so on. So you can fill in the entire tree. And then this diagram like this would only be a result of a wizard or end the visualization after you fill in the wizard. You can also use an instance table to create these instances. So these are very convenient for the simple feature model. So where you don't have this deeply nested feature models, but let's say you have only 10 or 15 or maybe 20 of these features, and you keep them in a single root feature group and don't have a deeply nested stuff, you can use an instance table and very easily create a, let's say, fancy configuration and pick a choice for each of the features in there, create a mainstream configuration. These configurations are then just rows in there. Okay, so now we covered, let me remind you. Okay, so we have these four things. So we covered the left-hand side, so the feature model and configurations. And then now let's jump into the right-hand side, so multivariant system model, like there. Okay, so the multivariant system model is just a normal system model. So you use whatever Magic Draw means for system modeling there are. So if you want to model requirements, you model requirements. If you want to model your blocks, you model in BDDs, IBDs. If you need activities, you model those. If you model state machines, again, you use normal Magic Draw system modeling facilities. But the important thing is that you annotate your system model with variation points. So basically you right-click any model element which you want to say it varies depending on the configuration. and you go to variance modeling and add a variation point in there. So you see in the screenshot in here, some things have this blue dot and with a letter V indicating that there is a variation point in this place in the model. So you see in the sunroof, which is in the screenshot, we have an existence variation point. So this variation point tells Magic Draw that this particular block, so this is a class model, but it should be, let's say, imagine it's a system model. So this particular block, a sunroof block, exists or not depending on the choices in your feature model. So that's what an existence variation point does. As I said, another flavor of a variation point is modification variation points. But for technical reasons, we kind of have 4 of the variation point kinds. So you see primitive property, element property, primitive tag, or element tag. All of them are basically modification variation points. So it's just slightly different flavors of that variation point. So if you want to modify some, let's say, a string or an integer or a Boolean field somewhere in your model, and you want to change a value of that depending on the configurations, that would be a primitive property variation point. If you want to change a field whose value is some model element, then you need element property variation point. So a case point in this screenshot in here, you see an engine part. And so there is an association between a car and the engine, and there is a variation point on this port. And pay close attention. Variation point is not on an engine block, but on a part of the engine. And this variation point modifies the type of the engine port, thereby rerouting this association to one or the other flavor of the engine, depending on the choices in your configuration in there. So that would be a more complicated case of the element property variation point. And primitive tag and element tag is the same, but not for UML fields, but for tag fields coming with some profile. So let's say requirement text would be a case of a primitive tag variation. If we want to change requirement text, that would be a primitive tag variation point, because we are modifying the text tag. So and this is a stringy, so that's a primitive type. So primitive tag variation point. Okay, so these variation points are then stored inside your model as a special stereotype constraints. Okay, we talked about these flavors of the variation points already. Okay, so now the important thing is that variation point, this variation point constraint, needs to have a connection to a feature model. It needs to have a connection to a particular features in the feature model, and by this connection we are declaring that this place in the model depends on the choices of these features in the feature model. So I would in this model here, when I define the variation point for a sunroof, so this is my sunroof block, and I would connect that to a sunroof feature inside my feature model in there, thereby declaring that this sunroof block exists or not, depending on the choice of that configuration feature. So this feature impact, they are modeled as relationships underneath, behind the facade, and as I said, these are declarations of what features impact this particular variation point, and those are very good for impact analysis and the coverage analysis things. So basically, once you have this connection between your variation points in the system model and features in the feature model, you can ask questions like which places in my system model this particular feature affect. So as you probably can understand that the single Boolean feature like a sunroof, yes, no feature in the feature model may have an impact on multiple places in your system model. So you have a let's say sunroof block in your car. You have some connecting wires going to that sunroof. You have a button in the panel. Maybe you have some software or firmware changes in the software or firmware change model in the system, so that there can be multiple places and multiple variation points in the system which are affected by this single feature in the feature model. And these relationships allow you to trace these impacts. And you can both visualize these impacts with the normal dependency matrix, and you can also actually enter or modify the feature impact. So if you have such a matrix, you can, dependency matrix in MagicDraw, you can double click in any of the intersections of these row and column, and by creating a new feature impact, thereby you declaring that this particular place in the system model is dependent on these features in your feature model. So it's easy to both visualize those feature impacts and to create new ones and modify. Okay, so up until this point, so again, let me recap. Okay, so now we talked about these three things. So both things on the left and the top thing on the right. So but this is, so to speak, upfront work. So it's not giving you any value. So what gives you value is the ability to then produce a variant system model. So this is a payoff phase. So the production of variant system models is a payoff out of this tedious and laborious stuff of describing your variants and annotating variation points and making feature models and making configurations and so on. So this is a payoff, so production of the variant system models. So we do have two facilities to derive variant system model. One is called variant preview, so for a quick inspection, and that's just a visual thing for the end user. And another is a variant realization, and this is basically a real model transformation which goes into the model and makes the prescribed changes to arrive at a particular variant. So let me show you a couple of screenshots here. So here is you see a variant preview inside. So basically, you pick from the MBPLE toolbar, you pick a particular configuration which you want to highlight, and MagicDraw goes into your diagram and highlights things that will be removed from the model under this particular configuration. So it highlights those in red. The things that will be changed are highlighted in yellow. The things that will be retained in the particular variant, those will be highlighted in green. So this is an example of a class model in there. So this is an example of an activity with some steps cut out. This is how the variant preview looks like. But this is, as I said, it's just a graphical highlight for the end user to quickly look into the variant. If you so basically, all the other MagicDraw mechanisms, such as, let's say, validation or simulation or, let's say, publishing, so all the model analysis features would still see the entire model, and therefore you cannot, let's say, if you have let's say some mass roll up in your car and you want to calculate a mass of your car out of the masses of the parts, until those parts are removed or retained by the proper variant realization, this calculation of the mass would include the entire model, so to speak. And since the entire model is 100 times 50% model, it would be bigger than the thing that is necessary. So to actually arrive at the model for a particular variant, you need to do a so-called variant realization transformation. So basically, there is under the tools transformations, there is a variant realization transformation in there. So you cut either the part, so you select a scope, so which could be either entire model or just a part, or let's say some package of the in the model, and you say I want to realize that this and this configuration, and the transformation goes in. In here you can see, for example, this. Oops, sorry. The sunroof and the spoiler has been removed because for this configuration it's not. It was switched off. So let's say number of doors. In the 150% system model, you see here the multiplicity for doors was from 0 to multiple, and in a particular variant now we have a specific number of doors, 4 doors. Again, maximum mass could be modified. This association has been rerouted to a particular type and so on. So basically transformation goes into your model and makes the changes. Here is the interesting case with activity diagram. So it's this cutting of the things in case of activity diagram is quite smart, meaning that if you have 150% system model activity like this, and you want to remove some steps like this detect car head, so the transformation is smart enough to rejoin your flows, so the flow is not broken if the step is being removed. So that's one of the smart things. Another smart thing is that you see here it can do the reachability of the branches. So we see here a branch on the right hand side which is for, let's say, ABS, some activities, and we only have a variation point on this transition here. And in a particular variant, if we remove this transition, magic grows. Okay, this entire sub branch is not reachable, so it needs to be removed. And the one when cutting, you see here the entire right hand side again is cut out, and the flows are rejoined, so that your activities are somewhat properly structured as a result. So here are some of the example results.
There is no need for slides, for those samples. Let's go to demo. Those are the cases we want to see live.
Okay.
Yeah.
Okay. So here is the same thing that I had in that example. So the feature model. So this feature model is inside a separate module. So let me open that. So if you want to see live, here is the. Let me show the same things in live. Okay, so this one is not. Maybe we'll use that as an example for an instance table. Okay, so here is my feature model, the same that I have been demonstrating or I had screenshots in the slides. So it's just as you see, just a class model with. If you look inside, it's just a stereotype, like a root feature group in there. And all of these features are just the simple properties, like sunroof in here, of the type Boolean, just apply stereotype feature. So you want to add another feature, just click in there, add a feature, something like this. So just be careful. You need to pick a proper type for your feature. So if a feature is yes/no feature, so the thing that can be chosen or not chosen, you use a Boolean. If it's an enumerated, like an engine property in here, you make a enumerated type and assign it to your property. So that's how you make enumerated features inside your feature model. And again, if you want subgrouping, you use this guy is root feature group, and these are just feature groups. So, but basically, they are both classes and with the properties inside. So here is a more complicated case of the. Okay, let me actually remove this thing. It just clutters the stuff. So basically, I have lamps in here, and the lamps can be of the 4 kinds. So simple filament lamps, halogen lamps, xenon lamps, and LED lamps. And the thing in here is that xenon lamps have a sub features. That situation you capture with this idiom in here. So you have a class and the subclasses in there, and let's say a xenon subclass has auto leveling and adaptive optics sub features. So it's not just a simple enumeration like we have for engine, but like this in here. Okay, and once you have these feature models, as I said, we recommend you use instantiation wizard. So right-click your root feature group, go to Tools, Create Instance, and here you have this wizard for creating an instance. You fill in the fields. So let's say for engine you pick this. For an exterior, again you go body. Okay, that would be a saloon. Body color, maybe some red. Again, chrome. Do we want active grille shutters? None. Alloy wheels, yes. Fancy grille, yes. Spoiler, yes. So yeah, so basically you see this wizard for instantiation. It's just for creating an instance, which would be a configure. So this would be a configuration. Let me create a. Okay, and you can actually, if you don't want, you don't need a diagram because these instances are quite easily editable inside the model. But let's.
And that feature modeling, is the diagram for that, or there is only stereotypes in class diagram?
So there is no dedicated diagram for this, but there is a basically.
There's DSL, right? Where you can pick.
Yeah, there is a DSL, but I guess my installation is a little bit old. But there should be an item here for creating a feature group and root feature group.
Okay, yeah, okay, that's what I was wondering.
Yeah, and that should be available for class diagram and BDDs. Mm-hmm. And once you place a block like this on your diagram, you can then create features from these things. So you create feature like this and create feature. If you have already some features, you can create it from here. So basically, you don't need to like right click and apply stereotype blah 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 in there. So these things are in there. Okay, so this is a result of our quick and dirty creation of a particular configuration. So the things that I have entered inside my wizard should be recorded in this instance model, and you can see them here on the diagram. Or, as I said, actually these values are not that needed in the diagram. You can access all of them inside your containment tree. So if you want to, let's say, change engine from the diesel to something else, you click it in here. If you want, let's say, sunroof, flip it in here. Yeah, or you can change the same thing in the diagram. So these are just normal instances in there, and they are not even stereotypes. So there is no specific stereotype for these things. So it's just a raw instance models in there, and your choices are recorded in these instance models. So and as I said, if you have something less complicated, like okay, I had a feature model. Okay, simple FM. Where do I have it? Yeah, so here there is a, let's say, simple feature model for trains in there, which does have just a few of these features. So whether it's a passenger train, whether it's long range, and what it's powered with. So it's just a rudimentary feature model. In that case, it's very easy to enter these configurations in the instance in the instance table. So you create an instance table, set your classifier to be your root feature group, and then each configuration is then a line. And if you want a new configuration, you just enter it here. So your new configuration, okay, maybe it's a passenger train. Come on, passenger train, long range, and powered by DC, maybe something like that. So basically, for each of the features in the feature model, we have here a column which you need to fill in, and the rows are individual configurations. Of course, you can do the same thing on a bigger feature model, but then basically we don't have a good solution in our instance tables for the deeply nested class model. So if you have a deep nesting like we have in here, your instance table would not be nice. But as I said, if your feature model is not deeply nested, you can use instance tables, and that is actually faster and easier and more visual than using this wizard to create your configurations. Okay, so these are feature models and configurations. Feature models are lightly stereotyped class models. Configurations are instance models. Okay, so let's return back to our system models now. So this feature model is used as module in my system model here. And this system model does have, so you see these letter V's in here. So there are, this is demonstrating various applications of the variation points. So this one is an existence variation point. So you would click in here and it would create you this existence variation point on a sunroof in here. So this variation point is telling that this block will not exist under particular configurations. So you declare your feature impacts, or what features are impacting the sunroof, by adding features here. So you can click in here and go to a list of the features which are coming from your feature models. So we basically listing all the properties which are stereotyped by feature. So I could say, okay, this sunroof is depending on sunroof block. So this guy in here is depending on sunroof switch in the feature model and the ABS switch in the feature model in this case. And basically you can use any, so if you have multiple features affecting a single place in the model, the expression, you could build a Boolean, quite complicated Boolean expression out of these features. So you could say if sunroof and not ABS, if sunroof and or ABS. So basically, in general, there is a so-called variability expression, and you would fill it in here using any of the Magic Draw's executable languages. So let's say JavaScript or Python or Groovy or Ruby, something like that. But in most cases, or in simple cases, you don't need to fill. So let's say, like in here, we have a simple case where just a sunroof switch controls our variation point. And in the simple cases, you don't need an expression, and Magic Draw will derive that expression automatically for you. So it's not necessary for you to be a programmer, quote unquote programmer, and know these languages to build a complicated expression if your cases are simple. So as in this case, it is simple. One Boolean is controlling one existence variation point. You just leave the expression as is, and Magic Draw will derive it for you. But they can be, okay, I'm not sure. Do I have? Probably, yeah, I have. Okay, so if I look in here, so basically this maximum mass field property, value property in your system model, it has a primitive property variation point, which tells, okay, so it does have a feature impact to a body. So basically, body type in the feature model does have an impact on this on the default value of this maximum mass field. And so here I do need some expression because it's not a simple like yes no thing, but I'm saying if the body is S state, then my default value of this field will be 1350. If body is cabriolet, my maximum mass will be this, and otherwise it will be that. So there is already an expression in here. So in here, as I said, this is a more complicated case where I need to change a type of this part property. So that would be an element property variation point in here. And I say, okay, it depends on engine. So there is a engine feature in my feature model, which is just enumerated. And I'm controlling the type field. So I will be rerouting this to something in here, depending on the condition. But in here, I need to build a condition in a so-called case table. So I'm saying if an engine is gasoline 2.2, then the type of my engine property will be this guy. So atmospheric gasoline. So the type will be come on. Sorry, it's a little bit laggy. So in case my engine in the configurations is set to gasoline 2.2, this will be rerouted to here. If the engine is diesel 2.0, then this will be rerouted to here. So yeah, so these are these more complicated cases. Okay, so these are some examples in the class/BDD models, but the same is applicable on any. So basically, any domain is amenable to control by PLE. So even if we are talking about the requirements, we can change requirements. So let's say there is a requirement for sunroof, and of course, if my sunroof is switched off in the feature model, I don't need that requirement. So there is an existence variation point on this sunroof requirement in here. So this requirement, I want to just change the text because I want a specific number in here for this text. Again, I make a primitive tag variation point, and in here, yeah, I do need a bit of code. So this is not a very nice expression. So it would be nicer if I just made two specific texts, like one text for one case, another text for another case. But here I want to just go inside and basically do a search and replace. So that's why this expression is not very quote unquote nice, but it's doable in a pinch. So you can do those. So here is an example of an activity diagram again, where I'm modeling the, let's say, braking process of car braking in here. And so if the car does have a front-facing radar, it can detect car ahead and maybe initiate a braking process earlier maybe. But if the car configuration is not advanced and it doesn't have a front-facing radar, so this step needs to be removed. So I have a variation point for that in here. And okay, so these two steps are common for all configurations, and this branch in there is only applicable if my car has ABS. So ABS is another choice in there, and I'm adding an existence variation point for this guy, and you will see that in this way I don't need to add existence variation points to all these things. So I don't need to have a zillion of existence variation points on these things. I only need one existence variation point on this transition, and Magic Draw will do reachability analysis and delete these guys automatically. So here are, so these examples of the application of the, so here we see a system model, 150% system model annotated with variation points. And once you have that, we can use preview capabilities to highlight the things that are relevant to a particular variation point. So in here you see that my fancy configuration will have both spoiler and sunroof. And so these things will be changed because, yeah, there is a documentation change on the car, there is a change on the doors and change on engine. So these are highlighted in yellow. So the things that will be changed are highlighted in yellow, things will be retained highlighted in green, things that will be removed are highlighted in red. So you can see in here, this requirement will be retained, this requirement will be changed. Again, in here, we do have so all these things will be retained. But if I pick a different configuration, let's say this cheap configuration for a mainstream user, it doesn't have, so for example, these things. So now these things are highlighted in red. And in here you see that there will be no sunroof, so this thing will be removed. The door count will be modified. The same for the system in here. If I pick yet another configuration, like I guess this guy. Okay, so this guy does have an ABS, but that doesn't have the front-facing radar. So it's yet another configuration different from this configuration or that configuration. So this is a visual highlighting of the things. And if you want to but as I said, this is just pixels on the diagram. In the real system model, nothing changes if you pick a different preview. But if you want to use model analysis tools like again simulations, reporting, publishing to our publishing systems, or let's say validating stuff, you do need to realize a variant, and for that you use tools model transformation either through here or from here, tools mod transform, and you pick a variant realization transformation. Okay, so here you pick a scope. So I will be transforming my system, my package in here, but you can transform the entire model. Okay, this third step is not relevant, so just ignore that. And in the last step, you pick a variant that you want to realize. So in this case, let's realize the mainstream 3. So let's see. Okay, so this was a fancy one. So yeah, but let's see what it does. Okay, so now if I let me actually compare this thing to what we had before and see what the transformation has done. So if I press Ctrl Z quickly, okay, so and let me highlight the mainstream 3. Okay, so as you can see, these two things have been removed by the transformation. Okay, so because they are not relevant for that configuration. This thing, so the engine, has been rerouted so that there is so instead of generic engine type, we are using specific engine type for this particular configuration. So if you see now okay, let me switch that off so that you can clearly see when you see multiplicity on the doors. It's from 0 to many in my 150% model, but if I realize a variant, you see that the multiplicity here has been set to specific. So my car has 4 doors in there. Again, if you see again the maximum mass, it has been adjusted from 1,000 to 1,350 in there. So you see this transformation went into your model and changed some stuff. Again, we can see that on the requirements, if you see I don't have a sunroof requirement anymore, and here is the particular number of doors now is embedded in this requirement text instead of this nondescript num doors thing, which was in which was in my 150% model. Again, if I look into this, if I do a variant realization, you see that for the mainstream 3 variant, so for this variant, this thing has been retained, but this thing has been removed. And as you can see, it's not just simply removed, but the flow has been reconnected. So you can see that the flow of your activity is not broken.